Today we're going to be moving on to bivariate data. And so there's no guided note sheet for today, so you're going to have to take these notes into your notebook. So if you do not have your notebook out, pause the video, take out your notes, take out your notebook, and get ready to start copying these down. So bivariate data. Bivariate, we're going to define what bivariate is first. Bivariate is used when studying two variables. So univariate, which we just got done, univariate was one-sided when we had one variable. Bivariate is when we have two variables. So an example of bivariate data could be time studying versus test score, because we can compare these two things together. The more time you spend studying, the higher your test score is going to be. So bivariate data is used to study two variables. And it can only be two variables that can be compared. How much we study depends on, our test score depends on how much time we study. If we're talking about apples and oranges, one does not have any effect on the other, so we would not use bivariate data there. Okay. When talking about bivariate data, we usually represent it in what's called a scatter plot. Scatter plots are used to represent data It also shows a numerical measure of strength. Numerical measure of strength and direction. So when we're talking about scatter plots are going to be used to tell us the strength and the direction, how strong it is, and then which way it's going, positive, negative, non-example. So down here we're just going to draw some scatter plots. And these are those graphs that just have some dots all over it, like so. So we're going to draw 4. Doesn't have to be perfectly like mine, you just have to have some of the points going in the same direction. Okay, number 4, this last one over here, I'm going to put off to its own little cloud, okay? We're going to talk about that one in a second. So now we're going to identify what each of these scatter plots look like. Okay, we said that it's used to represent strength and direction. The strength is called a correlation. Correlation is how they correlate together. How are they being compared? And then the direction is where is it going. If this was a line, okay, a straight line like we had graph lines before, what kind of slope would that have? Well, this is a picture of what would be a positive slope. So if your dots go up in this direction, it is called a positive correlation. So positive correlation. If our dots go down this way, if we had a line that went down, it was a negative slope, so here it's going to be a negative correlation. In this graph here, we can see that these dots are all over the place. There's no line showing positive or negative. These dots are just randomly placed, and that's called no correlation. And now this last one here I put off to the side. You may see this as an answer choice. It is never, ever going to be the correct answer. I wanted to show you what it looks like and what the answer would be. But remember, never going to be an answer. And that is undefined. Because remember, if we had a straight line up and down, vertical slopes, undefined slopes. So here it would be an undefined correlation. What we also need to say about our scatter plots and the points in the direction that they're going. The closer the values are to a straight line, the stronger the correlation. So if I had two graphs, okay, I'm just going to draw them down here. So here I have two graphs. Both of them are going in the positive direction. But if I had drawn an invisible line, okay, and I'm going to use a pencil to draw that line. If I had drew an invisible line here, whichever one has more points close to that line is going to be the stronger correlation. So if I called this A and this B, which graph would be a stronger correlation? Well, it would most definitely be graph B, because these points are very close, if not on that line that I drew.